Hello everyone, today I am going to explain an important topic in operating systems process management. So let's the foundation, understanding the core principles of process execution. An operating system is responsible for managing system resources and one of its most important tasks is managing process. Process management ensures that multiple programs runs efficiently without conflicts. Understanding processes. Process versus program. A program is a passive entity, executable file. A process is an active entity, a program in execution. Unit of work. A process is the unit of work in the system. It requires resources like CPU time, memory, files, and input-output devices. A process is a program. In execution, it is not just the code, but also includes current activity, program encounter, registers, memory. So basically, when you run any application, it becomes a process. Process control block. To manage processes, the OS uses a data structure called process control block. PCB structure. The OS maintains a process control block for each process containing process state and ID, program counter, CPU registers, and limit, and memory informations. It acts like an identity card for each process. Process state. A process goes through different states during execution. New process is being created and ready, waiting for CPU, running, execution in progress, working, waiting for input output preparations, terminate process finished. These states help the operating system track each processes. Since process scheduling, since multiple processes compete for CPU, the operating system uses scheduling. Scheduling decides which process runs first, how long it runs. This improves system performance and efficiency of the system. System schedulers. Short-term scheduler selects which process should be executed next and allocates CPU. Mid-term scheduler swaps processes out of memory to reduce the degree of multiple problem. A long-term scheduler selects which processes should be brought into the ready queue. There are some systems scheduling algorithms. Some common scheduling algorithms are FCFS, first come first served, SJF, shortest job first, and round robin. Each algorithm has its own advantage depending on the situation. Inter-process communication. Processes often need to communicate with each other. This is done using inter-process communication, such as shared memory. In shared memory, processes communicate via a shared region of memory. Fast but requires synchronization. The second one is message passing. In message passing, communication occurs through messages exchanged via the kernel, safer for distributed systems. And last is synchronization. In synchronization mechanisms like semaphores and mutex prevent race conditions during IPC. Versus processes. Characteristics in process. Memory address space is independent and isolated. In thread, shared with parent, context freeze time in process high and expensive. And in thread, it's slow and efficient. Communication in process requires privacy mechanism and in thread direct memory access. Resilience in a process less is isolated and in thread less can affect process. Context switching impact. When a CPU switches from one process to another, it is called context switching. The OS saves the current process state and loads the next one. This allows multitasking in the system. As the number of active processes increases, the context switching overhead grows, eventually leading to thrashing, where the CPU spends more time switching than executing.